Hello, hey everyone, and welcome to today's edition of Java for Everyone. I hope you guys are doing well. Um, so last week we were able to. Maybe I can introduce myself first. For those who don't know me, I'm Samuel Win. I've been running part of the Java for Everyone series of online bootcamp classes for the Kenya Java user group. And we've covered a bunch of topics. And we've gotten to a point where we are looking at Java collections just after going through generics and interfaces. All the previous code samples can be found on a GitHub that I've been sharing at the end of the class. So you can find them under this GitHub repository, just in case you are joining this for the first time. So today we'll start by covering, maybe do a recap of what we covered last time, then we'll look into today's topic. So maybe before I start, okay, I see a bunch of us have already joined. Hey everyone, welcome to today's edition of Java by Example, and Java for Everyone. And last week we were able to cover the Java collections interface, and we were able to also look at the iterator interface. So I hope you guys are doing well. Otherwise, today we will be going through the next step, which is looking at actual collections within the Java collections framework. So one thing I was mentioning is that you can find source code for previous classes under this GitHub repository, or if you during this class, if we did do something that you don't understand, or you have a question, or you just want to provide some feedback, or if I get something wrong, feel free to interrupt me so that I don't have to be moving back and forth between the meeting and the class itself. So just unmute and speak, or you can leave a comment. I'm sure there's somebody from our organizing team who will be there to assist. I've seen Ian. Ian has joined. How are you, Ian? I'm good also. Welcome to class. Awesome. So let me just go ahead, because today we have so much to cover. So I'll just go ahead and start. But maybe before I do that, does anybody have any question from last week? Yesterday, was it Tuesday? From Tuesday's class, when we looked at the collection interface. Maybe you looked at the source code and you had some questions. This would be a good time. Okay, if there's no question, then I guess I really did a good job there. So if you guys understood what we covered, that's really good. So then let's go ahead and start. If anything happens, you're not able to see my screen, or and if there's any problem, just let me know, so that we can have a productive session. Okay. So just a recap of last class, which was on Tuesday. We created this freezer collection, and we had created it in the class before Tuesday. So last Tuesday we just enhanced it by making it generic. We were using objects earlier, and we were able to see how by making this collection generic, we can use it to store a large variety of types, but we were also able to limit those types by using bounded generics, like so. And we saw that using bounded generics helps us to have an easier time writing some of the collection interface methods like this contains function that goes into the collection and checks whether it contains a particular element. So apart from that, we were able to also look at the iterator interface. So we created this freezer iterator, and this iterator allows us to iterate through the members of the freezer collection. And we learned that the iterator interface also supports generics. So we can write an iterator that is generic, which means you can use it with any type, but also we were able to apply bounded generics by limiting the iterator to any type that extends from flavor. So we looked at the hasNext method, which allows you to check the next element that we iterate over. And we were able to look at this next method, which supports retrieving elements from the collection itself. And we saw how the iterator interface and the collection interface work together. So you can see within our freezer collection, we have implemented this abstract function from collection interface, and with that we were able to pass in the freezer iterator as the iterator for this collection, and we were actually able to use it in our main function, where we used it to iterate over the members of our freezer collection, which is this list of ice cream flavors. So that's what we covered last time. So today we are going to move the plot forward. If you have any questions about the stuff we covered, don't worry, just unmute or leave a message, and we'll be able to assist. So today we will move out of the tradition of doing things ourselves just slightly and move into utilizing things that are available within the Java language, and in this case specifically within the Java collections framework. So for this class we are going to create a new package to keep our source code, and I'll call this package collections v2, because it's collections, but now it will be a bit different from the approach will be a bit different from what we used last time. So here I'll just have a compact Java file, just like the other one. We can call this main v2, and we can use this. I'll just remove the class declarations that it's a compact file. I think I can even get rid of the package declaration. So what are we going to go through today? So today, Lord willing, we'll be able to look at lists, and the other thing we'll be able to look at is ArrayList. I'll explain what these are, and then in the next class after this, I'm expecting that we will be able to look at LinkedList. So let's start with the list. So what is a list? So a list has certain characteristics, but to best understand it, I'll state the most obvious characteristic the list has is that a list is an interface. So list is an interface. So if you think about it in terms of the Java language, where we have classes, we have interfaces, we have enums, enumeration types, we have several types within the language. A list is an interface type. So that is foundationally what it is. And what that means for us is that a list will likely contain abstract methods. These are methods that don't have an implementation, and it will contain perhaps default methods that we looked at on our interfaces recap. So those are the things that we expect a list to have. And it being a list, an interface, we also expect that there should be an implementation. So this depends on implementations. So you need an implementation for you to work with a list. Because it's an interface, the methods that are declared there don't have an implementation. So you have to find an implementation or create your own implementation. So just like we saw with the collection interface, we had to implement the interface. Using this implements keyword, we had to implement the interface, which gave us the abstract methods that are declared in the collection interface, and we provided functionality for those methods. And if there were any methods that we were not able to provide functionality for, we threw this unsupported operation exception. So in terms of language level, within the Java language, a list is just like a collection is an interface, which means it contains abstract methods. It might contain some default methods, which means they come with some default behavior. And also, it depends on an implementation. So you have to have an implementation. So from OOP, these implementations are also referred to as concrete classes. So you need a concrete class. So you can think of our freezer collection as a concrete class. So this freezer collection is a concrete class for the collection interface. It has implemented the abstract methods within that interface. So the other thing that we need to remember is if this list interface has, because the list interface has abstract methods, the concrete class, the ones that implement this interface, they might decide not to support some operations. And just like us, that's why we started with trying to implement our own, some of the interfaces that are available. So just like we did with the methods we were not able to support, we'll just trigger an error. And the most common error that's used is unsupported operation exception. So anytime we are trying to use these concrete classes or implementations of this list interface, and we run into unsupported operation exception, we should know in the back of our minds that that just means our implementation doesn't support that method, although it's declared in the list interface. So I think with that, we probably have, at the language level, we have a clear view of what a list interface should be. So in terms of data structures and algorithms, what is a list? So a list wraps, it has the capability of wrapping a dynamic array. So the same way we did with freezer collection, you'll find a lot of similarities with what we did last time. If you look at the implementations of lists, you'll find that they are housing an array one way or the other. So it wraps an array, but the difference between that array and the one we implemented for our freezer collection is that that array is dynamic. So the array that we used here is fixed size. It's not dynamic. We don't have functionality within our freezer collection to expand this array. And that is why expand or contract it, whichever direction. If it is initialized with these elements, if those are 10 elements or 5 elements, we are limited to those 5 elements during the lifetime of that freezer collection. We can't change it. And that is why, if you look at some of the methods we were not able to support, it was this add function that's supposed to add new elements into the freezer collection, a remove function which is supposed to remove elements from the freezer collection. So if you're adding, you have to expand the array. So if it was 5 elements, you need to move to 6 elements. We're not able to support that because our array is fixed size. So the concrete implementations for the list interface, majority of them, I believe perhaps most of them, have support for dynamic array, which means the size can change. So you can keep adding elements and the implementation will handle that dynamic nature. They also use something called insertion order. So insertion order means the elements are stored in the order in which they're added. So that is something that will become important as we go forward. But the other one that we can borrow from what we've done is that they are indexed. They are index based. So I remember when we were looking at this freezer iterator, and we actually had a few problems here, and we were able to solve them by making sure that we match the index of the array correctly. And because I've told you guys the concrete implementations of that list interface wrap a dynamic array, and the way you reference elements in an array is through indexing. So when you're working with any concrete implementation of list, you'll notice that you can use index-based access, just like we were doing. So index-based access just means you can reference the array itself and then pass an index, pass an index, and that index will give you the element. So call back to the arrays class. So the same behavior is borrowed by list interfaces. So since they're index-based, the other thing you need to know is that they're zero indexed, which means the indexing starts from 0. So if you guys remember from the previous class, this means if you have an array that contains 3 letters, 3 characters, this array, the index of the first element, which is A, this index will be index 0, not index 1. So this will be at 0, this will be at 1, and this will be at 2. So that's what we mean by zero-based indexing. So when you're accessing elements from a list, just like when you're accessing elements from an array, you have to keep in mind that the first element will be at index 0, not index 1. Very important. As we saw last time, we ignored that for a bit, and we were able to see that triggered some errors to emerge. So to avoid covering too much theory, maybe let me state the last property that we need to be familiar with. So here we are talking about lists. The other thing is it allows duplicates. So within a list, you can have A at index 0, you can have B at index 1, you can have C at index 2, and you can have again B at index 3, you can have another A at index 4 in this case. So it allows for duplicates. You can have duplicate elements. The other thing that lists allow is they allow nulls. So you don't need to worry about null. So allows nulls. So you can pass in a null into a list and you'll not have a problem. So you, just like with our example here, let me just copy what we have. So within this this same list, you can have at index 5, you can have a null value. So you can have null, and this is a null at index 5. So it allows duplicates and it allows nulls. There are other collections that will find that they don't allow duplicates. And when we get to that, you'll be able to see the difference. So if you are writing a piece of software that is sensitive to your collection having null values, then you might want to avoid a list or have your own custom code that ensures that nulls are not inserted into the list. Okay, enough theory. Let's do something interesting, which is writing some code. So I'll just create a main method here for us to start exploring. And maybe before I go ahead, does anybody have a question regarding the theoretical concepts we've looked at for the list? Yes. Yeah, so Dennis is asking whether we are going to dive deep into the illustration or in the insertion order. So we are going to be able to see this with code samples. So I believe it's best demonstrated with code. When you do a sample, it will become more clear. The only theoretical thing that you need to remember from that insertion order point is that the retrieval order is not guaranteed. So if you are so let me just so retrieval order is not guaranteed. Yeah, so the same way you inserted the elements, when you're retrieving them, you will not be able to retrieve them always with the same order. It's not deterministic when you're retrieving, but during insertion you can insert them in the order. They'll be arranged in the order you inserted them. So when you are retrieving by index, the same way you do with arrays, I want an element at index 0, I want an element at index 5, you'll be able to get the right element. But if you are doing a bulk retrieval, you are saying, give me all the elements that you have. When they are being returned, the order might be shuffled. And the reason for this is, although we are going to discuss it a bit more, is the dynamic nature. Because the array that, the collection that you're using, as you add the elements, that array keeps changing. That's why I'm saying we'll be able to see it when we do the code, okay?
Insertion order is guaranteed, so in line 11, if I add C3, it can come the last element.
Yes. So when you do get at, so let's see, line, you said line?
11.
Yeah, so if you say get 1, you'll get B. If you say give me the element at index 1, you'll get B. It will not give you 2. It will not give you C or A.
What if I add, so I add C3, it will go to the last type?
So if you add, so there are two ways you can add. You can add by specifying an index. So that will do some swapping for the values that are there, depending on the method that you use. Also, if you add without specifying the index, then it will just make that the most recent added element, I think. Yeah, but we'll see this more with the code samples. Yeah, but that's a very important point. Thank you for asking. So that and the dynamic aspect and how it affects how you write code, those are very important, and we'll be able to visualize them well. So before we work with the lists, this is the problem here. If we want to create a list, like I said, you can find list in java.util.list, I believe, yeah. And you can see it's a generic type. So just as is our tradition in this class to look into the Java source code. So you see, a list is an interface, okay? We covered interfaces, so this is just an interface. So this is how it's implemented inside the language, and it's a generic interface, which means it can support multiple types, and it's not bounded, which means you can essentially pass anything here. And it extends sequenced collection. Sequenced collection just means we have an intermediary between us and the collection interface. So we were able to implement the collection interface directly. For us, what we did is we implemented the collection interface directly, but what sequence collections is it extends the collection interface, and then it adds abstract methods, some additional methods that we'll discuss, we'll go through, and then now the list interface now implements that. So a list interface extends collection interface indirectly through an intermediary. The intermediary is sequenced collection. So the thing with interfaces is you cannot instantiate them directly. So if we said, and I expect for those of us who have been in this class, probably this is preaching to the choir. If I say a list, and this is my list, is equals to new list, I'll have a problem. I cannot do that because list is not a class. It requires us to have concrete implementation for us to start using it. The same way we have the freezer iterator that implements the iterator. So you cannot instantiate iterator directly, but I expect that we know that already. So how are we going to be able to get a list? So the way you get a list is by using one of the available concrete types. You can use an array list, or you can use a linked list. There might be a more, but for this class we'll be looking at this too. Yes, anyone? I had a mic open. Is there a question? Okay. If you have a question, just interrupt me. I'll be able to tell from the mic, and I'll be able to answer. Also, if somebody sees a chat and you're able to unmute, let me know so that I can read it and respond. Yeah. Oh, okay, cool. Nice. So let's see. So the way you can create a list is by using one of these concrete types. So there's a survey that was done among Java developers, and the interesting thing is like 90% of Java developers use list amongst all the available collection classes, collection types. So within Java we have lists, we have queues, we have sets, we have maps, but the most used collection is the list. So we are starting from the sweet part of the cake. So this will be very important. If you have any questions, feel free to ask so that you get this. So for this, we'll be using one concrete implementation, which is ArrayList. Again, just like it's our tradition in this class, we are going to peep into the Java language source code and try and see what is this ArrayList. So unlike the list, here, list is an interface, but ArrayList is a class, and that class implements list. ArrayList implements list. Of course, it implements a bunch of other things that are not important for us at this time, but the main thing is it implements the list. So if we create an array list, we can use that to instantiate a list. And of course, because it implements list, we can imagine there's some abstract method that's declared in list that is implemented here. So that, at least that we know. One thing I wanted you guys to see is, you see this is an array, right? If we go to our freezer collection, this is an array. So have that in the back of your minds. It will be important later. Okay, so then, so I've said we are going to use ArrayList. What is the difference between ArrayList and list? It might not be very important right now. What you might need to know is that the most important thing to know is ArrayList is an implementation of list. LinkedList as well is an implementation of list. So if we go to, if we look for LinkedList, let's see what the Java language has. So you can see LinkedList is also a class, generic class, and we can see that it implements list, but it implements other things. Most notably this, but you can ignore that for now. What we are focusing on is that it implements list, which means we can use it to initialize our own lists. Awesome. So let's go ahead and use ArrayList. So how do you instantiate using ArrayList? So the way you do this is, first of all, list is generic, which means we might need to specialize that to specify the type we want to store. So for this example that we are starting with, we just want to start simple and create a list of numbers. Let's say numbers. It will be integer numbers list. So it will be integers, but just let's call it numbers list. And this numbers list is going to be the parameterized type is going to be integer. So we've done generic. So when we talk about parameterized types, I believe I'm preaching to the choir. So then the next thing you do is just, of course, say new is equals to new array list. And voila, there you go. You have an array list. And that is our numbers list. So currently our numbers list is empty, but we would like to start doing some interesting things with it. So one thing I'm going to try and do is I'm going to try and check the size. So first of all, let's try and access some of the functions that we had in the freezer collection, just to see whether there is correlation. So let's see if we have size. So if I call numbers list dot size, size. Oh, I see there's a size function, and this should give us the size as int. So number of integers. If I want to, of course, I'm getting a lot of suggestions from the ID here, but let's ignore them for now. So the other function we had is empty. So if I want to check whether it's empty, of course that will give me a boolean is empty, and we can call numbers list number of integers dot is empty. Sorry, numbers list, which is the collection. Okay, just to avoid confusion, let me just call this list so that it's shorter and also I don't confuse it with the other variable. And I'll call is empty on it. What is the other function we had here? We had contains. Let's see if we can call contains, which also returns boolean. Contains list dot contains, and we can say, does it contain 45? 45. And we'll get a response. So this is the thing that you should notice is the functions that are available, that are declared abstract in the collection interface are now, yes? Okay. The functions that are declared in the collection interface are now available to us as within the list interface. And that is the consequence of the list interface also being an interface that extends from the collection interface. So that's why those functions are available there. So the inheritance hierarchy is you have the collection interface, then you go to the list interface, and then you go to the concrete type, which is ArrayList, or in future we'll look at LinkedList. And you can see the functions that we are working with under freezer collection are now available to us. Let's go ahead and print some of this, so that we can be sure that our code works. So I'm going to try and get the size. So the size is available there. The other thing was whether it's empty. Is empty, and is empty is just that value of is empty, and I'll go ahead and print contains 45, and that will be contains. So if it contains 45, we expect this to print true. Is empty, we have not added anything to it, so we expect it to return false. Contains, we expect to be false as well because we haven't added anything. And number of integers should be 0 because it doesn't have anything. So let's see what happens. So size is 0 as expected. Is empty is true because it doesn't contain anything. Contains 45 gives us the value of false. So it's working as expected. So it's working just the same way the freezer collection was working. So now let's try and add some elements. So how do you add elements? You add the elements by calling an add function. And there's a variety of add functions. There is add by index, and there is add where you just add the value. So the functions that are available are add, this add where you can add a value. Let's say I want to add the 45 that I was looking for, and there is list.add, which allows you to specify an index. So you can pass in an index here, and then you pass in the value. So let's say I wanted to add at index 0. So at index 0, and I want to add my value is 45. So there's no problem if I use int here because of auto boxing, but I believe we learned that in the OOP class and when we're working with interfaces and partly through generics. So from the generics class, we know why we cannot say the type here is int, because generics does not support primitives. So I believe there we should be in the same page. So there's no problem if I do this because Java will automatically convert it to integer and I don't need to worry about that. So you can add by index and you can add the value itself. So so for this second add, let me try and just change it to another value, maybe 44, something different completely, maybe 11. And let's see what happens. So first of all, I'll disable this just to see if our initial add works. So we are just adding 45, and you add by calling list.add. And let's see if what we'll get for the value of the size is empty and contains. So I'll just run that. And now we see with that, the size of the list is 1 element because we only added 45. Is empty returns false now because it's not empty, it contains an element, and contains 45 returns true because we passed in the value 45. So just to make sure it's not a fluke, let's pass in 55. See whether contains will return a different value. So contains 45 is now returning false because it doesn't contain the value 55. So I'll just change this back to 45. And yeah. Any questions so far with the add function? Okay. So that's good. So let's see what happens when we add to an index. So we are telling the list that add this value, but I want you to add it at a very specific position. Particularly, I want you to add it at index 0. So let's run and see what we get from that. So now we see that the list contains 2 elements. Is empty returns false. Contains 45 is true. Let's see if it contains 11. So here contains, so let me just have 2 of them. So contains 45 and contains 11. And since you guys know what that does, I'll just call it inline here. Contains 11. I'll keep the contains 45. Perhaps I could so inline them. I can do contains 45. So this will check whether it contains 45, and this will check whether the list contains 11. And let's see. So contains 45 is true, contains 11 is true. So we know the values are there. What we don't know is whether the value 11 is at the index that we specified. So how can we tell? So that's where we go to the next feature of the collections, which is the ability to retrieve values. So with these 2 functions, we're able to add values. So this allows us to add elements to our list. Let's look at retrieval. Retrieval. But before I go to retrieval, within the collection interface, there's another interesting method that we might need to check whether it's supported. There's this method add all, which allows you to add a list into another list. So you can add more than 1 element. So let's see if that is supported. So I'll just attempt to call add all, and you can see we have add all, and it will accept any collection whose elements extend integer. You guys remember the wildcard feature? So that question mark, this question mark here, comes from the wildcard feature that we covered in generics. So for member variables within a generic type, you can actually use the wildcard to also limit which values can be accepted. So collections is generic here, yes, but we want a generic collection, but the parameterized type has to be within this range. We covered that. If you have any questions, just ask, but that's what this means. So there's two variants. There's one where you pass in an index and you pass in a collection, and there's one where you just pass in a collection. So let's use the first one. And what we're trying to do is we want, instead of adding one by one, we want to add multiple. So what we can do is create another list of integers here, and let's call this list B, and this will be ArrayList. At least we know now how to initialize that, and we just pass in that list B, and you can see that it's accepting it because this list is a collection and the argument accepts a collection. But instead of passing it empty, let's give it some elements. Let's add maybe add 80, and so let's see if we're able to add another value like 99. So we've added 45 to the original list, then we've added 11 at index 0, and then we've gone ahead and added these two, which are from another list. We've taken list B and we are inserting it into list A. And our initial list A here, let me name it appropriately. List A. If you are going to have a B, we should have an A. So our list A, let me try and utilize the ID for this. I want to replace this with list A. So initially we have list A, which contains 45, and we've added 11. We've created another list B, which has 80 and 99, and we are adding list B into list A. So let's see what kind of effect we get from that in terms of the size, but also, okay, let's start with the size first, just to see what kind of behavior we originate. So now we see we have 4 elements, and those 4 elements are the 45 we added here, the 11 we added here, and 80 and the 90. So that should comprise 45. Is empty is still returning false, which means the collection is not empty, and 45 is still inside, and 11 is inside the list, which is list A. So this is how you can insert multiple elements into the same list. So let's discuss retrieval. Let me just comment this out briefly. So to retrieve elements, there's some functions you can use. You can use, of course, they are called getter functions, just like getters that we have with our POJ or plain old Java objects. So there is a get function within multiple variants of get functions within this list interface that the ArrayList, of course, conforming to list interface has to support. And there are variants. So the way you call get is by passing the index, so the index of the value you want to retrieve. So that is the most common way of retrieving a value. So you call a list.get, and then you pass in the index. So as an example, let's try and see from our experiment what will be at index 0. So we started with adding 45. So when we added this, we expected that it will go to index 0, because index 0 is a start. But then here we said the next value should go to index 0. So let's see what happened inside the array list itself. So list A, we can call get on it, and you can see there is a variant that it requires the index. We'll look at this other two later, but they mean their name. They are like get first and get last do exactly that. They get first and get last, but we'll look at them. So now let's try and see what is at index 0. And this will be, I'll call it int value at index 0. It's a very Java way of naming that variable, and we'll go ahead and print it here. io.println and value at index 0 is value at index 0. So let's see what value holds that very important position. So if we run this, we'll see that value at index 0 is 11. So what happened was 45 has been dethroned, so it's no longer at index 0. So we can guess that 45 will now be at index 1. So it's been pushed down, but let's be sure. Let's see what value is at the next index. Value at index 1. So value at index 1 will be get, and then we pass in index 1. And we can utilize this print function and say value at index 1 and value at index 1 is that. So let's see what the value at index 1 is. So value at index 0 is 11, because we specified here that you must put this at index 0. So value at index 0 is 11, and the value is 11. Value at index 1 is now 45. So I think, Dennis, this answers the question you had, at least partly, about the insertion order and the retrieval order.
Yeah, it does, because I can see, I think when we were adding 11 at index 0, it shifted 45 to index 1. So my question is, do we have any value at index 2, or index 2 is non-existent?
Oh, yeah, that's a very good question. So the best way to know is, let's try and retrieve value at index 2 and 3 and maybe even 4 and see what happens. What do you think?
Yeah, we can try and see what happens.
Okay. So what we're going to do is, so we're able to retrieve the value of at index 0, which we now know the behavior. If you pass a value and you specify the index, it will adjust it. Let's try and retrieve an index that we know might not be there. So let's get the value at index 2. Remember, we only have 2 elements in this list. So let's see what happens. So I'm going to go ahead and print that value at index 2, and that will be our value at index 2. Let's see. Oh yeah. So if we do that, we get an error, and this is not a strange error to us. It should be very familiar. We've seen it before. We get an index out of bounds exception, and it's telling us yes, Dennis.
Yeah. I'm just agreeing.
Yeah. So it has detected that we are trying to retrieve value at an index that does not contain a value. So it's able to give us an index out of bounds because the length of our collection is currently 2 elements. Okay.
Yeah. Just to ask a question, because ArrayList are dynamic. The length of the list will shrink or expand as we add or remove elements, right?
Yes.
Can it be considered crazy if, when I'm creating the list, I specify the size?
Very good question. In fact, that's what I was to go into next. Let me first explain it to the rest of the class, and then we do the experiment. What do you think?
Yeah, because I was thinking if maybe I specified the size to be 5, maybe index 2 will be there. So we'll see when we get there.
Yeah. So let me first explain to anybody who doesn't know whether you are actually able to specify the size. And then after everybody in the class has understood that you can actually specify the size and what that means, then we try and specify a size and see whether now we'll not get the index out of bounds error.
Okay.
Awesome. So thanks, Dennis, for that. So let's see. So we've looked at retrieval. So now we know if we try and retrieve an index that doesn't exist, we get an error. So if you ever are working with your code and you run into that error, index out of bounds, just know that, or you are trying to retrieve an index or a value that doesn't exist in that collection, or you're trying to determine a position that is not present in the collection. But this position being present or not, it's a bit of a complicated story but it's important to understand any time that if that error pops up in your IDE or in production or anywhere, just know, oh yeah, there's I made the mistake of probably trying to index something that doesn't exist. So important to remember. So now let's look at the other thing that Dennis has brought up, which is very important, and that is we talked about lists being wrappers for dynamic arrays. And we know from our example with the freezer collection is you can actually determine the size of an array. So the way we are using a freezer collection is the size of our array here, which is elements, is determined by the caller of this. It's determined at the instantiation of this freezer collection. The instantiation phase is in this main method where we are saying new freezer collection, and then we are passing ice cream list. So ice cream list has 1, 2, 3, 4, 5 elements. So this freezer collection internally will have an array of 5 elements. So this will be 5 elements. So that's a fixed size. So that's how we've determined the size of this the elements within this freezer collection. So how does ArrayList do it? ArrayList does it differently because our array there in the freezer collection is fixed size. It's a static array. ArrayLists are actually dynamic arrays, which means the size can change. The size changing is very important because if I'm instantiating this array list and I'm adding elements, internally inside Java, they cannot give me an array of infinite size. Like say they give me an array of 1 billion length. So it goes into your computer's memory or the server memory, and it takes up that amount of memory just in case I want to store 1 billion elements. So it's not able to do that. But at the end of the day, it needs to have an array that's instantiated that I can add things inside. So also it cannot be 0. Because if it is 0, if the size of that array, and when I talk about array, just know it's this that's wrapped inside. And when we looked at the insides of the array list, we notice there's a similar manifestation. There's an array inside there. So this array cannot be 0, because if it is 0 and I try to add something, there won't be a position for me to add that value. So it has to preserve some amount of memory for me to start using. So how does it do that? So within Java, it provides a particular amount of initial size. So this array list will have a particular initial size. If I remember from the theory, the initial size should be about 10 elements, but I think code doesn't lie. So let's see if we can find that. Unless, yeah, I think I've already seen something like that. So there's this variable called initial capacity. So here we are inside array list, We are looking at the ArrayList source code, and it has this variable called initial capacity. It has this variable called size, and it's talking about initial capacity. So initial capacity is not exactly a variable. I'm just looking at the internal. Okay, I think we can just look at this constructor. The constructor will guide us. So these are constructor within the ArrayList. I'm sure we are familiar with constructors. And this constructor is expecting an initial capacity, and it checks whether if the initial capacity is greater than 0, and then it does what? It creates a new array of that capacity. If the capacity is equals to 0, it uses this empty element data. So this empty element data is just an empty object array. But then this, I think this is the variable I was looking for. So there's this variable within ArrayList, and this variable is default capacity. So, and the Java doc describes it as the default initial capacity, and the capacity is 10. But to best understand it, let's look at where it's used. There's this function ensure capacity, and I think there should be another function here that can. There's another function called grow. So this is the grow function is used to expand the array, and another place I believe it's. So those are the only places it's used. So it is used in this function called ensure capacity. So it's used to set the capacity. So the ensure capacity looks at minimum capacity, checks the length of the array that we have, and then it does another check here. This just checks whether it's empty and whether minimum capacity is less than default capacity. So then it does things to expand or to set the initial size of the array. So without going too much into this, essentially what happens internally is anytime you initialize an array list without specifying the size, the default size of your array list will be able to support 10 elements. So if it is able to support only 10 elements at the start, what happens when you add more than 10 elements? What should happen? What happens is the internal Java code will expand the array. And the way it expands the array, it creates a new copy of the array with this new size, and it makes it the current array. Remember, the array list is wrapping a regular array, which we're able to see there. But the default capacity for that array is 10 elements. Now, so whenever you do this, just know internally within Java, this is an array of 10 elements internally within the array list. If we add more than 10 elements, Java will look at the size and then it will expand it. In fact, it's very specific on how it expands, and how that is done is it will expand it by 50%. So by default, so we have an array of 10 elements. We had element 1, so 0 index, you add the first element up to the 10th element. This is index 9. So when you are adding, if you add index 10, which will be the 11th element, what Java will do, it will look at the current size of the array list. In this case, the current size is 10 elements, and it will increase it by 50%, which means the new size will be 20 elements. So from theoretical aspect of it, that's essentially what internally a Java language should do. As a developer, you can change this behavior. You can decide, for instance, one of the things that Dennis was alluding to is we can change the initial capacity. So we saw this initial capacity here that's defaulted to 10. Yes?
I think I have a question, maybe. If you don't mind clarifying, there are two things here. I think there are two concepts here. There is capacity and there is size.
Yes.
Because in line 16, when we create list A, we don't specify. So by default, the capacity is 10. So the maximum number of elements you can hold is 10.
Yes.
But then if we check the size is 0. So size and capacity are two different things. So capacity is the maximum number of elements the list can more or less hold without resizing.
Thank you so much for pointing that out. That is very, very important, and I almost glossed over it. So size and capacity cannot be used interchangeably. They mean two separate things. Thank you for pointing out that, Dennis. So the size is the actual elements, the actual values that are stored inside the collection. So 45, 11 here that we added, initially we added 80, 99, that will determine the size. So when we call list a.size, it would go and check the actual values that are inside the array itself. Capacity is the length of the array. How many elements can you continue adding before the array is expanded? Before internally Java says, okay, you've reached the total size of this array list, now we are expanding it. We're giving you more space. So Dennis, thank you so much for pointing that out. So you should always remember that those are different things. I'm sorry I glossed over it, unfortunately, but the size and the capacity are very different. So what I'm referring to here with the number 10, this is the capacity. So the capacity, when we first initialize this array list, the capacity is 10. But the size, just like Dennis pointed out, the size is 0. It doesn't contain any element. But the capacity is 10, which means it can house 10 elements. So that's very important. So Dennis, there's something you asked that brought us into this question. Unfortunately, I might have forgotten my train of thought. Has it been answered, or can you rehash it so that I remember?
First of all, it's actually Dickens, not Dennis. Then,
sorry.
I think the question was if I have the option of specifying the initial capacity of the list when I'm creating it.
Yes, yes.
Then if I specify that this list should have this default capacity of 20, I thought that if I specify that, it might solve the problem we were getting with checking if index 2 has a value, but then I think it can't.
Yeah. I think that's what led us here. So maybe I can describe that. Before you decide that it can't, let's see if it can't.
Okay.
Yeah. And sorry, you and Dennis have the same voice. And I'm not switching back and forth. So I must have confused you. So sorry about that. Sorry for confusing your name. Okay, cool. So we talked about size and capacity, and we at least now we know that for an array list the default capacity is 10, which means before it is expanded by the Java collections framework, before it's automatically expanded for you, you have an initial size of 10 elements before that expansion. But the size of the elements is the actual values that you've stored. So you can think of this as you have 10 boxes that are empty. So initially I give you 10 boxes, they are empty, and yes, you have 10 boxes, but you don't have 10 items because the boxes themselves are empty. So if you add an item into each box and the box reaches capacity, I can go back to the store and give you 10 more boxes. So now you have 20 boxes, and you can continue adding values to the boxes. Again, if you fill up the 20 boxes, I do a 50% increment, I give you 20 more boxes, and you can try and fill the remaining boxes. So that's how it works. But as a developer or a programmer, you can change the initial capacity. And the way you do that is you use one of the constructors that we glossed over here. There's a constructor that was here that was accepting initial capacity. So currently we are using this constructor. We're using this one. This one, it doesn't accept any value. When you initialize with this, it goes to default capacity element data, which is that. But there's another constructor that accepts initial capacity. And let's see what the Java doc says about this initial capacity. So the initial capacity of the list. So they didn't describe it more. I think by now you guys perhaps know what that means. So it means here we can say, hey, I want 50. Give me an array list that can store 50 elements. So if you specify the initial capacity of 50, the initial size of the internal dynamic array will be 50. So now if you fill that 50 is when you'll get the 50%, I believe. So you'll get 100. So so the reason why this is important, although as a beginner it might not be too crucial, but the reason why it's important as a developer when you're writing your programs, and that will be the central theme even when we cover future topics, is you need to worry about performance, because in production environments you end up storing a lot of data. You might go into a company and there's 10 billion customers, and there's a database that has the data for these 10 billion customers. So as a developer, you have to be mindful. If you try to process all the 10 billion customers in one go, you'll probably end up using all the memory on the server will crash, and then you'll have created an internal DDoS attack. So other people will not be able to access the service because you as a programmer, you decided to pull 10 billion customers from the database and fill them in memory. So you have to be very, as you write production applications, you have to be very mindful about how you are using memory, how much hardware resources you have, and what optimizations can you do here and there so that you get some extra performance. One of the optimizations developers do with the ArrayList is this initial capacity field, because the resizing of this dynamic array is an expensive operation. So by expensive, so the resizing is expensive. So you saw that grow function that we saw in the ArrayList. It's an expensive operation because first it has to copy your current array list. So it has to copy your current list, basically take everything, and then it has to place that into, first of all, it has to initialize internally it has to initialize a new list, and then it needs to copy the values that it got from the original list into this new list, and then it needs to return that to you with the new capacity. So that might end up being performance intensive, and it might end up overusing some of the hardware resources. So some developers, if you're in a constrained environment, you can decide, okay, because I know my elements are going to be 50. So why start with 10 and then it's resized twice or 3 times, and then when the second resize happens, they'll give me an array that's bigger than the elements I need. Why not just tell the framework that, hey, I'm working with 50 elements here, so when you're giving me the array list, give me an array list of 50 elements. I'll work with that. I will likely never require an expansion or a resize of that array list. So that's why this field is important. So back to what Dickens was asking, and I hope I got that right this time. Where is he? Okay, maybe I should use your last name. Okay, so what he was referring to here is if when we do this, when we don't pass in the size and we try to check the size, if we don't specify the size, if we try and check in, let me just comment out some of the stuff we've done here so that we can run this experiment. Double commented this. Okay, so let's see the size before we specify. So if I say size of list A, so if we check size of list A, list A dot size, so this will give us the size. Let's see what it is. So size of list A is 0. So we might think, okay, it's 0 because we have not initialized with any capacity. So let's have a different list here, and this other list, call it list B. Let's have it with a different size, with different initial capacity. Again, I'm using those size and capacity interchangeably, but they are different, as I explained. So I'll just go ahead and say, okay, so size of list B is list B dot size, and if we print that, we'll see that it's 0. So regardless of the initial capacity that we set, remember this list A and list B, in fact, I'm using the same 10 value. So list A and list B, they are both being initialized with a capacity of 10. So internally you have an array that is capable of supporting 10 elements. But they are both giving us a size of 0. Because when you call size, it goes and checks whether they are elements. If there are no elements, then the size will be 0. So it checks the actual elements, not the capacity of the array list. So it doesn't count empty boxes, in other words. So if this was 30 and we run it, we'll see it's still 0. So it's kind of the same as this, but they are not the same as we have learned. This one is capable of storing 30 elements before array size happens. This one can only store 10 elements before array size happens. So you can use that initial capacity construct argument to avoid the resize operation. Dickens, does this cover it, or there's an aspect that we might have missed?
It does cover. It covers.
Okay, awesome. And thank you for bringing that up. It's very important.
Okay, no worries.
Awesome. Anybody else with a question?
Hello, Samuel.
Hey, how are you?
I'm fine. I think I don't know if I am right. Dickens was trying to say, because the list A array, the initial capacity is 10. Like when we try to get an element at index 11, we'll get like out of bounds. So can we try like getting in list A, we try like getting an element at index 11, and maybe at list B, we try getting an element. We see if at maybe like 15, we see if we'll get a null, something like that.
Nice. In fact, thank you for pointing that out. I think that's also another important aspect we can look at. So since you guys already know that we can do this in line, so I'll just go ahead and do it in line. So here, what we are trying to do is list A index 5. So we know list A doesn't contain anything, but it has a capacity of 10. So if we try and retrieve the value at 5, are we going to get anything, and what will it be? Then we can also try and look at list A at a quote-unquote valid index. So sorry, invalid index, because capacity is 10, so at index 5 we should have a value. So let's go beyond the size, go to index 13 and see list A dot get at 13. So let's see how this works with our list A. Okay, so we are getting index out of bounds at, in fact, the first attempt. So although this is quote unquote a valid index because the capacity is 10, internally it's able to check whether we actually have elements at that index. So it will not give us null or have some undefined behavior. It will actually check, yes, this array list is capable of storing 10 elements, but it doesn't contain anything at index 5. So we'll still get an index out of bounds error. So I think that's important for experimentation. If we go out of bounds, let's see what happens if we go out of bounds, because 13 of course will have gone out of bounds again. And yeah, the framework is smart enough to check, and you can see here it's returning the length as 0 despite knowing that the initial capacity is 10. So there is some internal mechanism that's able to check, yes, the capacity is 10, but are there values at those indexes? Is that more clear?
Sam, can we print the list? We see what is there.
Yes, that's a good idea. It's only that it will take us to another topic. I like the way we are doing it with like experimentation, but this is good. So what Ian is bringing up is the idea of bulk retrieval, right? Ian?
No, okay. We can not go to the bulk retrieval way. We just like print the list itself, like print list A.
Oh, okay. Oh, using it to string.
Yeah.
Oh, okay.
Even without the toString, I guess it can print.
I mean the default toString value.
Yeah, just IO dot that list A.
Yeah. So I'm sure everybody else. So just for me to safely do this, that nobody is lost. What Ian is talking about is what we're going to do is go to the array list. I don't need to go to so we're going to go into this array list and tell it to print back the elements it contains. And there are toString functions that are available for that. By toString, I'm sure you guys must have learned this in the OOP class. You can have a toString function, and the toString function just prints the member variables of the class. So if I'm doing, so yeah, I'm just printing the elements. So elements in list A. So if I do this concatenation, list A, like that, what I'm essentially doing internally is at this point we'll do a list A dot toString, so that it's not explicitly called, and it will try and stringify, create a string representation of the elements in list A, and the format in which it prints those elements is using these brackets things. So you'll see something like that outputted. If you have any questions about this toString call, just ask so that you are not lost in this. So that's what we'll be doing in line 25. We've seen that these ones will throw exceptions, so I'll just remove them from here, just in case somebody tries to run that in future. I don't know if this, so we have list A. Yeah, I want to keep list B for the experiment. So let's print the elements in list A. So we'll see we are getting this. So it doesn't, so it goes in, checks whether there are any values, actual values to print, and it finds that it's empty, and we are getting that empty printout. Ian, does this, did you expect this to happen?
Yeah. I just wanted to see like why. Yeah, it just kind of validates why we're getting the index out of bounds.
Yeah, despite the capacity being within bounds, right?
Yep.
Yes. So it's every time we're interacting with the API, at least based on the calls that we are making, the list and array list have the intelligence to check for actual elements. So that's another layer of safety. So for both of them, we are getting that. What would happen if we have a value? So let's add a value to our list A. In fact, with this we can Did we add elements? Okay, just to make it clear, perhaps let's do it up here. We already learned about this add function, and we can use that to add a value. Like I've added 43 to list A. In list B, I'm also going to add a value. Add maybe 66. And let's see what the so you see the printout will print that. If we have more than one element, they are comma separated. So if we have also 33, if we have 11 there, and then with this one we have let's have a different value like 55, and we have 88. So if we print that, we'll see list A as 43, 33, and 11. List B has 66, 55, and 88. So you can use this to print out the elements inside a list. If it's a complex object, maybe you're trying to print out ice cream flavors, it will also ask your ice cream class, do you have a toString function? And it will use that toString function to print the individual ice cream flavors. But for integer, of course, the toString function is explicit, so it will just print out the numbers. Any questions? Okay. Yes?
I have a question about the grow function. You said it increases when it reaches the capacity, it increases by 50%.
Yes.
So if it was 10, you said it will be 20. I was wondering, the 50% of 10, is it not 5? So like it becomes 15.
My bad. Yeah, so it will increase 50% of the current capacity. So that will be, if it is 10, it will be 15. If it is 15, it will be something between half of 15, 7 point something. It will be 7. Yeah, so it's 50% of the current capacity. Thank you so much for that. Any other question or comment?
Can I add something?
Please go ahead.
So in line 34, you said add index, the new size 20 elements. So by 50%, supposed to be 15 or?
Oh yeah, I need to correct this. So this will be 15 elements now. So it will do a 50%, it adds the 5, and then you get 15 elements. And then again, it will do a 15% of the other one, round it off to integers, because indexes are integer based, so it can't be a float value. So it will round it off, and that will be the new capacity. So let's say if we are moving from 15, approximate half of 15 would be 7, right?
7.5.
If we round it off, that will be... If we round it off, it will be either, I think it will be 8. If you truncate it will be 7. If you round it off, it will be 8, right?
Yes.
Yeah, so if internally this is rounded off, you'll end up with 8. With 8 additional, that is 15 plus 8. How much is that?
23. Yeah.
Yeah. So it will essentially be doing that as you add more elements. If you reach capacity, it does the expansion. The main thing to remember is anytime you're adding more than the initial capacity, the array will be resized. So if you are sensitive about using hardware resources, it means you'll be using more memory. CPU time for expanding the array, actually running that grow function, and then additional memory being taken up. So as a developer, thinking about that might help you write slightly more efficient programs. Okay. Any other question or comment?
Sam.
Yes.
On these manipulations of indexes, can we on an empty list, that is, can we specify on a given index a certain value regardless that the list is empty?
Yeah, you guys are so creative. Yeah, we should try that actually. So let's go back to having an empty list. I'll leave list A empty, and what we're going to do is let me just get rid of this printout, and we know list A has no elements, but its initial capacity is 10. So internally, we are thinking, okay, inside the array list, there's an array, and this array can support 10 elements. So can we throw something at index 7, although index 0, 1, 2, up to 6 doesn't contain anything? So I think that's the question. So let's just do it in practice. And what we are going to do is add. So let's add 100 at index. So let me just make these variables so that it's clear for anybody else. So we are going to add it. So we know the initial capacity is 10. So we are going to add it at index. Let's add it at index 4. And we pass that as the index here. And let's see. So the way we're able to validate the index, by printing out we won't know. So the way we're able to validate is we call a get, and we call a get at the index we inserted the value, and see whether we'll get the value. So int retrieved value.
Some line number 19 is, should the index come first, then the value?
Oh, sorry, I mixed that up. Yeah, so it's index. Yeah, thank you for pointing that out. So it's index and then the value. So the value is 100. That's why it's important to name your variables. So value here is 100, so index and then value. So we're passing in 100 at index 4. So now when we call get, which value will we get? So we can do IO print line, and we can say value at index, that index, which is the index we specified, which is index 4, is this value, and the value is that value. So retrieved value. So we expect 100, but let's see. So I'm getting an index out of bounds for index 4 size 0. Oh yeah, so it seems you can't even insert at that index if there are no preceding values.
I think you need to start at 0.
Yeah. Insertion order. So you need to start at 0 down to 4. So if we,
because the actual size of that list is 0 anyways. So trying to insert at index 4. Yeah.
So the capacity is 10. Yes.
So the size is static; it cannot change.
What do you mean by that?
What I mean is that you have to start. If you are filling a list, you have to start from the offset 0 going onwards.
Yes. So yeah, you have to start at 0 going onwards. And I think that's a mechanism that's implemented by the ArrayList itself, because normal arrays don't have that behavior, right? Although with normal arrays, they are static, so when you're initializing them, you've already placed the values where they should be. So this is, we are dealing with a manifestation of the ArrayList itself. So back to your point, yes, it's static. You have to insert them in the correct order. I think that's why we talked about insertion order is maintained. So you have to start inserting from 0, then proceed to the other indices. You cannot start at the middle unless E0 has already contains a value. So if let's say if 0 has a value, Now that we know the constructor layout, I think we can just experiment without having the variables. I hope I won't confuse them again. So we start at index 0. We insert 100 at that index 0. If we move to index 1, we're able to insert the value. Let's say we insert 55. And now let's, in fact, I'll just skip this and skip all of that as well. And what we're going to try and do is, so value at index 0 should be list a dot get at index 0, and the value at index 1 should be list a get at index 1. So I think this we've preserved the insertion order, so this should work. So yeah, so we're able to see that 0 is at that and 55 is at that. If we used Ian's method here to simplify that as well, although no, that will not give us the index. So let me just stick with this so that we can explicitly ask for specific indices. Now let's do something else that's strange. Let's try and skip one index, go to index 2, index 3, and add in 99. If we try to retrieve, so my expectation is that we will get the same error we got last time because we skipped 2, but let's see how the API behaves. Yeah, so this is, I'm going to 3. Let's see if it's index 3 size 2. Still haven't added. Yeah, in fact, it doesn't even register this operation. So you have to preserve the insertion order. I think that should be clear to us. Very important. Insertion order is maintained, is reinforced. I think the right word should be reinforced. So you can't just add things willy-nilly. You have to move from 0, 1, 2, so on. That's why in production applications, you'll notice the way insertions are done is through bulk updates, and like we did where we had list A and list B, and we just added list B into list A. Because if you add one by one and you add them by index, you have to be careful about the indices. The other thing that also alleviates this problem is there's an alternative add function which doesn't require an index. So you can just add like that and the indices will be handled, and now when you retrieve, you could retrieve by index like that, which, yeah, this is interesting. So if I went ahead and tried to retrieve 3, of course, knowing that the insertion order is preserved, this predictably will cause the error. So if the capacity, if the size is 7 elements, you know that from index 0 to index 7, there's a value that you can extract, even if that value is null, because like I said, nulls are supported. So you can even pass null. So it goes up to 2. So you can even pass null, and you'll see we'll get our null there with no incidence. Okay, any question? Comment? So just a recap of what we've been able to cover. We were able to look at, introduce the list interface. We looked at it, we saw that it's an actual interface, it's generic, which means it can handle any type, not just integers. So this can be string, it can be double, can be anything. And from our generics class, you guys will definitely understand all of the internal mechanisms behind that. So we're able to look at the list interface. We're able to discuss some capability of ArrayList. We've gone a bit into advanced features unexpectedly. The capacity thing is usually an optimization technique, so I was expecting that we will cover them later. In fact, it was not me who was going to cover them, but I'm glad we were able to bring the spirit of experimentation and cover it within this session. So that was fun. We're able to look at the get function for retrieving element. We're able to look at the add function and their variant. Maybe before I close this, I'll be a bit greedy and cover two get functions because they are very simple and I don't want it to take up next lesson. So there's get first and get last, and just like the name, this one will obtain the first value and this will get the last value. So if the array is, so this if the array list or the list in this case has 1, 2, 3 elements, if you call get first, you should be able to get 100. If you call get last, you should be able to get null. So I'll replace some of these with those convenience functions because they are essentially built for convenience. And so with that, we don't need to pass an index. So I just know it will give me the last value. So value at last, and this will give us value at first. So let's see. They're very self-explanatory. They just do the thing that you expect. So value at first is 100 because the first value inserted is 100. Value at last is null because the last value inserted is null. So we're able to look at that. If anybody has a question about get last or get first, feel free to ask. Otherwise, they're usually self-explanatory. There are more advanced things that happen with this, but we'll look at that much later. So don't overlook them because they look very simple. They are very, very important. In fact, critical to what we are going to cover later. So we're able to look at the theory of capacity, and we're able to look at bulk operations through this add all function that adds all elements. And I think with that, we can conclude with the promise of next session. We'll be covering more about list. List is a very powerful and dynamic API. That's why that survey that I mentioned earlier, it was discovered that 90% of developers and 90% of production applications prefer this collection over all the other collections. There are some special use cases that force you to use a different collection that list doesn't support because of some of its limitations, like the retrieval order thing and insertion order, and also I think the main thing is allowing duplicates because there are collections that ensure that you don't have duplicates, the collections that we will discuss later on. So I think that's what we're able to cover. So next we'll be looking at additional features within the list interface, particularly bulk operations. We'll look at behavioral contracts between list and ArrayList, and we'll look at some of the things that only ArrayList can do that are not defined in the list interface. And then we'll discuss some performance optimization, additional performance optimizations, and most importantly, we'll also look at some functions that were added in later versions of Java. Starting with Java 9, there's some specific additional capability that was added to list and ArrayList, so we'll be able to look at that. And also we'll look at another method of initializing lists different from these two other new methods. So today we looked at initializing with an empty constructor for ArrayList, initializing with an initial capacity. So there is two more that we will check out in the next session. So I hope that makes you excited for the next session. The next session will be on Tuesday, same time. We usually have these sessions on Tuesday 9 p.m. East African time and Thursday 9 p.m. East African time. So Ian, it's East African time, right? That's the time zone we are in.
Yeah, East African.
Okay. Awesome.
Kuna mtu hapo East Africa kwani? Kwani local.
No, I'm doing YouTube live stream also, so somebody might be in a different time zone.
Oh, you're live on YouTube. Sorry.
Yeah, I'm also live on YouTube. So I'm being like a producer and teaching here at the same time.
Oh boy, man. Okay.
Yeah. So maybe Ian, you can mention a few things about our programs in Kenya Java user group and what guys can look forward to apart from Java for everyone.
Java by example tomorrow.
Oh yeah.
Is it there, Sam?
No. I'm still trying to recover.
Okay.
Yeah, but we'll be able to resume it soon. I can promise we'll be able to resume it soon, where we look at advanced things like actually writing server-side applications and stuff like that. We usually have them on Fridays, but I took a short pause to recuperate and recover. I was like super exhausted. I was doing like 3 days a week, and it was a bit tough.
Yeah, that was a lot. That was a lot. Yeah.
Yeah.
So yeah, normally those are the sessions we have, and then we'll, I guess possibly from next week we can have a session on Saturday. But I'll communicate. We will start having the sessions on the Saturdays, where we like talk about like more Spring Boot and whatnot, like specific topics like test containers, like such kind of things are what we'll be having, like we used to normally have them. Otherwise, I guess that's all. We'll share the link for the merchandise next time. I don't know if they can check it out now, but we'll share all the links because we normally have merchandise as well that we sell. So if you wanna get some, feel free to check them out. I guess that's all.
Okay.
And if you have like a suggestion for a session for the sessions that we have on Saturdays, just feel free to reach out. Let me know, and then we'll organize and get a speaker for you to speak about that specific topic.
Awesome.
That's all. Yeah. And then Sam is sharing the link for the project, for the repo, so you can air out your issues there.
Yeah. Even if you don't contribute code and you see a code sample that you don't understand or have feedback on, you can comment it and share it with us, and we will be able to assist in explaining. There are so many people in the group that are really good experts. Some of them are better experts at this than I am. So if you have any question, don't hesitate to ask, and you will definitely get a lot of assistance. Otherwise, all the source code is backed up into this GitHub repository. Yes, Ian?
No, I'm okay.
Okay. Otherwise, like Ian said, go to our merchandise store, which you can find in Kenya Jag. If you go to Kenya Jag, kenyajag.zenlipa.co.ke, you will find our merch store here, and here you can shop for some exciting hoodies, very well made, and t-shirts at very affordable prices. So this goes towards supporting the community and helping us create even more opportunities for learning through meetups and stuff like that. So check that out. Yes, Ian, you want to say something?
Yeah, and if they want us to center that, we can center it for you.
Oh, we are Java developers. We don't know how to. If you are given this,
centering this is not our thing.
Yeah. If somebody gave me that, if they gave me a whole 20 years, I would not be able to do it. So that's that. The other thing I would like to mention is primarily I work on this product called Life Planner. It's a productivity tool that covers personal finance and productivity. If you want to support me directly, want to support my work directly, go check out Life Planner. It's available on Google Play and the App Store, and I'll appreciate. Otherwise, I think that means we can call it a wonderful session, and I'll see you guys again next week on Tuesday and Thursday. Have a lovely weekend, and see you guys next week. Okay? But if somebody has a question, you can ask. But I think we can close it there.
Yep.
Yeah. Have a wonderful one, guys.
A nice one too. Bye.